हेलो फ्रेंड्स। आप सब कैसे हैं? आशा करते हैं आप सब अच्छे होंगे। तो चलिए आज स्टार्ट करते हैं। आज का टॉपिक है ओजोन लेयर डिप्लीशन। बिफोर स्टार्टिंग दिस वीडियो, आई रिक्वेस्ट टू ऑल माय फ्रेंड्स to share and like my video and give your valuable comment if you have any query. So let's start. So what is ozone? Ozone is a tri-oxygen is an inorganic molecule with a chemical formula O3. It is a pale blue gas with a distinctively pungent smell. It is an allotrope of oxygen that is much less stable than the diatomic allotrope, that is oxygen, O2. So breaking down in the lower atmosphere to oxygens. As you see that the bluish color, this is the ozone gas as identified, and this is the chemical formula O3. Okay, you can see this from this slide. There is a electromagnetic radiation that is coming from the sun, and around the earth there is a layer is present, ozone layer, and it is present in the stratospheric zone. Okay, this layer is protect the ultraviolet radiation that is coming from the solar radiation. So next is there is ozone. So basically ozone is two types. One is good ozone, or it is called as stratospheric ozone. Another is bad ozone, and it is called as tropospheric ozone. So let's discuss about the good ozone. What is its importance? Why it is called as good ozone? Okay, so it is present in the stratospheric zone. So it is called as ozone shield or ozone layer that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone molecules in relation to other part of the atmosphere. The ozone layer was discovered in 1913 by the French physicists Charles Fabry and Henry Buisson. This presence of ozone layer in the stratosphere is of vital significance for all biota because the harmful solar radiation such as ultraviolet ray, which are lethal to life on the earth, are not allowed to enter the earth atmosphere by ozone umbrella. It is act as a protective umbrella, okay, in the stratospheric zone. So next is the thickness of the ozone layer is measured in Dobson unit. Why it is called Dobson unit? Because this thickness was first of all discovered by the meteorologist GMB Dobson. Okay, here one Dobson by 1 DU, that is Dobson unit, is equal to 0.01 millimeter of the compressed gas at STP, as standard temperature and pressure. The normal range for the thickness of ozone layer is 300 to 500 Dobson unit. So actually, as you have discussed, the ultraviolet radiation that is coming from the sun, it is categorized in three classes, that is UVA, UVB and UVC. So UVA, that is a certain range, then for that it is categorized. UVA is 400 to 315 nanometer, UVB 315 to 280 nanometer, UVC 280 to 200 we can say, or 100 nanometer. Okay, so what is why the UV radiation is harmful? Actually, UV radiations can be harmful. It causes various diseases when it coming to the earth atmosphere. It causes a series of diseases. Okay, starting from the skin cancer. Skin cancer is one of the prominent disease due to UVB radiation. The main cause of sunburn, excessive exposure can also causes cataract, immunosystem suppressions, and genetic damage also happen. Genetic DNA changes. Okay, and there is a genetic mutation that can be also triggered by the effect of UVB. Okay, so UVC is also very harmful for all living things. Okay, we'll discuss a lot about this. What is the effect of ozone hole depletions later on. So now discuss about why, how it form. What is its formation of ozone. Okay, it is formed by two processes. One is actually it is in synthesis process. One is decomposition process. Okay, during synthesis at the upper part of the atmosphere in stratospheric zone, diatomic oxygens is photodissociation is takes place, which is wavelength is less than 240 nanometer, and that is divided to that is dissociated to two atomic oxygen. Okay, then once again one atomic oxygen again combine with one diatomic oxygen along with a third body. Okay, so that combines to form O3 molecule plus third body. When you come to the decomposition process, the O3, the ozone molecule, is decomposed or break down in the presence of wavelength that is around 230 to 320 nanometer. It's break down to diatomic oxygen and a singlet oxygen molecule. Singlet oxygen. Okay, that singlet oxygen is again combined with ozone molecule that is present in the stratospheric zone, and that form two diatomic oxygen separately. Okay, here M is neutral third body. Usually M may be a dinitrogen molecule or oxygen molecule. So what is the mechanism of the ozone depletions? As you know, X plus O3, that is which indicates to the reactant side is XO plus O2, and XO when combined with single oxygen, again it form X is separated from oxygen, and oxygen is combined with single oxygen to form a diatomic oxygen. So the net reaction is O plus O3 and O2, and two diatomic oxygen is formed here. That means O3, you can see this O3 is again break down to form two diatomic oxygens. That means there is a depletion of ozone is happening. Here X is the reacting species. These are the free radicals such as HOX. HOX may be H hydroxyl radical, peroxy radicals. Okay, NOx or CLOX. Okay. Next we come to bad ozone or tropospheric ozone. Why it is called as bad ozone? In tropospheric ozone, there are also some, there is ozone is also present. So they are called as ground level ozone. It is not emitted directly into the atmosphere, but is created by chemical reactions between oxides of nitrogen and volatile organic compounds. And this happens when pollutants emitted by car, power plants, industrial boilers, refineries, chemical plants and other sources chemically reacts in the presence of sunlight. Okay, so they form a smog. For the formation of this smog, this tropospheric ozone plays a significant role. Okay, smog is a secondary pollutant and ozone is also a secondary pollutant. Then we come to next. So here you can see that NOx, BOC, volcanic volatile organic compound, plus heat plus energy, heat and energy we can say, that is sunlight, they form ozone, okay, which is equal to ozone, and that ozone is plays a significant role for the formation of smog. Okay, so next is okay, this is one of the most important thing, that is many student is confused regarding the formula of the ozone depleting substances like chlorofluorocarbon and halogens. Okay, there is five types. There is CFC11, CFC12, CFC113, CFC114, and CFC115. Okay, I have explained very simply. You can see one carbon by four bond. Okay, in case of CFC11, there is 3 chlorine is present, 1 fluorine. CFC12, that is 2 fluorine, 2 chlorine is present. Very easy trick. Okay, when it comes to CFC1 and 3, then you just keep in mind that there should be 3 chlorine and 3 fluorine. When it comes to CFC114, you just keep in your mind there should be 4 fluorine and 2 chlorine is attached with carbon. Okay, when we talking about CFC115, only one chlorine is present and all are, that means 5 fluorine is present. Okay, this is the basic formula that you can easily remember. So here is CFC and at its atmospheric lifetime. CFC 13 is 101 years, CFC 114 is 236 years, CFC 115 is 522 years. Okay, it is the atmospheric lifetime of the chlorofluorocarbon. And halogens, then halogens are the extinguisher, fire extinguisher you can say. So these are halon, that is their formula is H1211, halon 1301, halon H2402. These are the chemical formula. You can easily remember these things. Okay, the next come to next, what are the effects of the ozone depletion and the bad ozones. Okay, so we can say what are the effect, as you know that ozone depletion means that is the very thinning, that is the concentration of ozone that is present in the stratospheric zone. Okay, it become thinner and thinner due to the due to the interaction of chlorofluorocarbon, nitrous oxide, halogens. These are the chemical formulas or chemical substances that is emitted by the human activities or anthropogenic activity, and these are responsible for the depletion of this ozone layer. Okay, so what are the effect if once the ozone layer is depleting, or it get very lesser and lesser, the concentration become very lesser, then what is the negative impact? What are the negative impact on atmosphere, on animal, on plant lives, or human beings, or the life present in the earth? Okay, so these are the ozone layer depletion increases the amount of UVB that reaches the earth's surface. So UVB causes non-melanoma skin cancer and plays a major role in malignant melanoma development. So mostly the skin cancer is one of the indicating disease due to this UVB radiation or UVB radiation effect. UVB radiation affects the physiological and developmental process of plants. It also it's also negatively affect the developmental process of the plants. UVB radiation has been found to cause the damage to early developmental stage of fish, basically it's marine animals. They also affect the developmental stage of marine animals. Mostly the plankton and zooplanktons are greatly affected by the exposure to UVB rays. It also the biogeochemical cycles, there are some alterations takes place. Okay, and next is the breathing ground level oxygens, as we have discussed, the bad ozone. Okay, that can trigger a variety of health problems that includes coughing, throat irritations, congestions, emphysema, okay, asthma, bronchitis. So these are the series of pulmonary diseases, and that is caused by the ground level ozone pollutions. Okay, so these are the related to lungs diseases. Okay, then we come to next. Okay, guys, you can see the two picture. This one is the hole, that is ozone hole. You can say this bluish area, and this is the over the Antarctic zone of the Earth. Okay, so this is the earlier photo or earlier image, but during COVID-19 situation or this pandemic situations, there are some restrictions were there, the lockdown and shutdown. So most of the vehicular pollution or emission was stopped, and the pollution level was lesser. For that reason, that hole is recovered. Okay, we can see. So mostly it is the vehicular pollutions or CFC pollution, chlorofluorocarbon, nitrous oxide, halons. These are the series of chemicals they are affecting, or they are mainly creating the ozone holes. When these pollution are become very less, there is ban on these chemicals. There is ozone depleting substances. The ozone hole become again it regenerate and it can recover. Okay. So some of the important points are the ozone related to ozone day, that is on 16th September. The theme of this year, that is 2022, is global cooperations protecting life on Earth. 2021 is Montreal Protocol, keeping us our food and vaccine cool. In 2020 ozone for life, that is 35 years of ozone layer protections. These are actually mainly asked in various competitive examinations and even in net examinations. Okay, what are the act actually or any conventions that is related to ozone layer protection, that is called the Vienna Convention. and in 1985, and related to ozone depleting substances. Okay, phase outing the ozone depleting um, substances. One protocol was there, that is called Montreal Protocol, that is happened in 1987. Okay, so thank you guys to watch my video, and please like and share this video. Thank you all.